minute. Really exciting presentation right now around data science. This is something near and dear to my heart. I've implemented machine learning projects before. It's something I find insanely interesting, and it is absolutely the forefront of the analytics journey we all want to take. So I'll be passing it on to Max and Juan to give you a great overview of what data science is and how we can really empower your organizations to use this technology. So Max, Juan, over to you.
Thanks, Jake. I appreciate it. Let me share my screen here and let's get started. So welcome to today's presentation on business applications of data science and machine learning. My name is Max Parduner. I'm the data science and machine learning practice leader here at eCapital Advisors. And alongside me, I have Juan Malaver, who is our data science and machine learning consultant on our team, who will be leading portions of the presentation today. Thank you guys for taking time, and let's get into what we're going to be talking about today. So what we're going to be talking about is what is the typical data science workflow? Why is data science a team sport? The industry and functional applications of data science and machine learning, some of them. And then we'll deep dive into a case study and demonstration of fighting customer churn. And then we'll wrap up with how eCapital can jumpstart your data science and machine learning journey. So what is a typical data science workflow? Well, it starts and ends with the business in mind and the business problem that we're trying to solve. So what's very important is for the data science team to ask the business a ton of questions about the problem they're facing and really understand, what is the current process, what is the current baseline for that process, and how would a machine learning or data science model augment that process, and how would they consume the outputs of the machine learning model. Once the problem is narrowed down and the problem set has been defined, then we enter the data acquisition and marshaling phase. And before I continue, I do want to point out that I've kind of boxed certain areas of this cycle with relevant tools that can help speed up the process, and I'll wrap that up at the end of the slide. I'll readdress that. So the next step is data acquisition and marshaling, and this is everything from connecting to all your different source databases and pulling in the data that you think will be useful for the study. And that's just getting it kind of all in one spot so that the data science team has access to it. But then you also need to do some data preparation, and that would be the next step, converting the data into a readable and usable format for a machine learning model. Next is exploratory data analysis. And in this step, you will be doing a lot of cool visualizations with the data to understand the correlation and how it relates to the problem you're trying to solve. And this also reveals some trends, maybe issues with the data that you need to address, and also what variables are going to be useful for the model itself. The next step is data modeling and evaluation with your data. And then if the model bears fruit, you'll think about how are we going to deploy this model and monitor it over time so that we make sure that it's still accurate. And then the final step, which is one of the most critical steps, is figuring out how, and this is something that should also be talked about up front, is how are we going to integrate this deployed model with the business process? What is that mechanism going to look like? And so the reason why I boxed these top two as Encorta potential is that on the data acquisition side, right, Encorta can connect to many different source databases with lots of different JDBC connectors and puts all of the data in Parquet files easily for the data scientist to access. And then on the flip side, once you've gone through the modeling process, which can be operationalized in Encorta, you can also spin up a dashboard that hosts those scores. And you can provide those business users with those scores to help them make more informed decisions and do their process faster. And that's just one way of doing it. But and then in the bottom half of the slide, there's the box around those 4 steps where I've pointed out for auto machine learning potential. And so what's really cool is we're in this space now where you don't need a ton of coding knowledge at this point to actually to do machine learning. And that's something that it really it makes me very passionate about this subject, because I want to take I don't want just to be PhD data scientists using data science and machine learning models in everyday practice. I want to help empower the business with these tools to help a savvy business analyst, put on a data scientist hat every once in a while, or be able to solve problems regularly for the business. And so that kind of leads into my next slide, where we talk about why data science is a team sport. So as you could see on the previous slide, as you saw on the previous slide, there's a lot going on, right? There's a lot of different steps in the process, and there's different skill sets needed for each of these steps, ranging from domain expertise, a la, who knows the business the best, that business function the best, that you want to become, best friends with as a data scientist, and understand, what their problems are and how you're going to help them. You're going to need some data engineering. Not all data scientists are great at data engineering as well. You're going to want someone with some, foundation of statistics and math, a concept of how machine learning works, and some computer science knowledge. But like, as I mentioned before, there are some tools in the auto machine learning space that help augment, some of these, areas where your organization might be deficient in regards to creating machine learning models. But I also just wanted to, call that out as, when you're creating a team, or thinking about how do I jumpstart my data science team, right? Thinking that you're going to find one person that can do all of these things is probably not going to happen. It's great if you can, but it's important to think about, what are the building blocks needed, and how am I going to support the data scientists and not put them in a silo so they can make meaningful impact on the business. And that's kind of the point of this. And we'll allude to this a little bit later on how we can help, make data science at your organization an attractive spot for a potential data scientist by enabling, technology and standing up some basic infrastructure that, get data scientists started quickly at their new job at your organization. So the next slide is around functional and industry applications of data science and machine learning. And really this slide, I know we probably have people from a lot of different backgrounds and organizations and functional areas here on the call today. And I wanted to kind of call out, some of the areas where you can use data science and machine learning. But of course, this isn't the end all be all, but just to kind of get your brain churning on, where can I apply data science in my organization? So starting at the top with supply chain, you can use, anytime you're really predicting anything, right? That's kind of the key word there. So if you're trying to predict demand for inventory management, you can maybe cut down the needs for your inventory and have them in on a just-in-time basis or whatever, or however you need that demand to organize your business and cut costs on that side, and meet your customer demand at the time that they want it, right? Additionally, you could think about optimizing resources with some of the data science model, machine learning model. In the finance side, forecasting is huge, right? Cash flow forecasting, top line revenue forecasting, expense forecasting. Anything with the word forecasting and has a time component, in my head that rings a time series model, and that is, and what's cool with that is, a lot of finance organizations, right? They use a lot of like driver-based forecasting, which are great, but it's also great to use some other methods as well in conjunction with that, and even prove out why maybe a time series model could be better in some cases, or a combination of a time series model and driver-based inputs can help, create a more robust model that can account for seasonality and things like that. And looking historically, right, at your business, you can see, okay, this is what I predicted, this is what actually happened. Now let's throw a time series model on that and let's back test it and let's see how it compares. What can we do there? And that's something we love to do. On the marketing side, there's a ton here. We're gonna deep dive into predicting churn today, so I won't go too much into that. But thinking about customer segmentation, things like customer segmentation, the propensity for one of those segments to accept an offer that you have, and then I started experimental design there because experimental design is kind of its own animal in that it's and Juan actually on the team is an expert in this, and setting up your studies so that you can measure how effective you are at engaging the audience you're targeting through a marketing campaign, and making sure that it's not just noise that's coming through, so that you can roll out with this once hopefully you have a model that predicts someone that needs engagement with your product or service, and then you're able to target your offers towards that particular sliver of your customer base, and actually see if that campaign was effective or not. And human resources, attrition modeling, recruitment modeling, something I didn't put on there, which I think is interesting, and a lot of big companies use these days, is like resume screeners with natural language processing. In the retail world, of course, churn is super relevant. But in addition to that, you can do some really cool things with that by actually giving a good measurement of customer lifetime value, and then also doing some basket analysis and recommendation engines. Think Amazon, Netflix, and these things aren't those models are open source, so they can be applied to your business. It's more around, can we get the data needed to create something with value there for your customers. And then in the financial services, I've spent a lot of time here working on data science models, and something that I've worked on is fraud and anomaly detection in that space, and then a suite of risk models for early prevention of risky accounts. So then we're going to take a little deep dive into customer churn, and my colleague here, Juan, is going to kind of spotlight some of the key pillars of the machine learning flow, as we discussed earlier. So with that said, I will hand it over to Juan.
Yeah, thank you, Max. And thanks everybody for attending the presentation today. Just to quickly reintroduce myself, my name is Juan Malaver. I'm a data science consultant at eCapital. I've been with eCapital for around 8 months now. I'm fresh out of college too. My background is in statistics, and yeah, it's really exciting to work in the data science industry right now. And it's very satisfying to see how we can build some solutions to help your business grow, to help your business succeed, and really unlock the potential of your data. So yeah, so let's dive into the churn case study. I'll walk you guys through how you can fight customer churn, and how you can frame a data science workflow to make sure that you're tackling it through using the proper strategies. So first of all, let's just define what is customer churn, right? So any business that has a product or service wants to add more customers, right? Because new customers will generate more revenue. And on the other hand, if those customers leave, then that's going to slow business growth. So businesses spend a lot of resources on marketing and sales to acquire these new customers, and they want to keep those customers engaged so they don't churn later on. So in this sense, fighting churn is essentially linked to unlocking a product or a service's full potential. And also fighting churn is equivalent to retaining customers. So what we do in a data science context is that we want to predict the risk that somebody will churn. We want to anticipate whether somebody will churn in the near future or not, and then do some sort of intervention to make sure that they remain engaged with the product or service. So, to do this, we're going to need a lot of data. We're going to need a transactional database to store all of this information in, and this is going to, tie into some of the data engineering strategies that I'll cover in the next few slides. But yeah, the main problem here, the main business problem, is customer churn, and we're going to look at some universal strategies to reduce it. So churn can exist for almost any product, if you think about it, any product or service, right? And obviously, for different products, the way that churn occurs, and that entire framework is going to be fundamentally different. But there are a universal set of techniques, a universal set of data science strategies that we can use to combat churn, regardless of what the product is. And here is a general outline of how that would work. So we first start out by measuring churn, which means we're pulling in raw data, raw customer data, and then calculating some sort of churn rate. That means we're basically looking at how many people are churning, and when are they churning, and why are they churning. And this leads to the next step, which is designing behavioral metrics, which are essentially summaries of customer behavior, summaries of customer events. And this is really where big data comes in, and efficient ETL processes really help streamline this process. After we have a data set built, we can then move on to a more statistical analysis, We observe churn historically, and then we predict, we forecast churn looking towards the future. And in doing so, in doing both of these, looking back and looking forward, we can start to understand why customers are churning for this specific product. So what variables are driving churn? Once we have a model built, we can then segment customers. We can group customers by the risk of their churn, and then identify similarities between them. You know, perhaps customers who are more likely to churn have some a similar set of profiles, and we can learn we can learn about their behavior by creating these segments. And then lastly, tying it back to the business problem, we can, you know, collaborating with other departments in the business, we can design an intervention strategy which incentivizes customer engagement. Essentially, you want to intervene to customers that are at high risk, and you want them to remain engaged with the product. So the first step in the data science workflow is getting the raw data and getting it into a format that we can use for analysis. And this is really the core of data engineering. We want to answer questions like, how do we calculate churn? You know, what does calculating churn mean? How can we calculate it? How do we measure customer behavior? Like, what aggregations can we make to summarize an individual customer? And then, you know, leveraging both of those, how can we create a churn data set that's ready for data science, that's ready for machine learning? So these are the next two steps in the data science workflow, which are going to be data acquisition, so pulling in that raw data, and you can imagine using a tool like Cohort, for example, and then preparing the data, preparing a churn data set that's going to be ready for subsequent analysis. Max, I think we can move to the next slide.
I think your connection might be slow.
Oh, did I freeze a little there? I'm sorry. I think we can move to the next slide though.
Jake, can you? No problem. It might be my internet.
Hey Max, I think it's your side. I can hear Juan perfectly.
Okay. Yeah, well, let's continue. So first step here is going to be measuring churn. Oh, I think, yeah, thanks, Max. So essentially, by measuring churn, I mean, we want to calculate a churn rate. And at a simple high level, you can think of a churn rate as the proportion of customers who leave, right? But the thing is, churn is a dynamic process, and that adds an additional layer of complexity that we have to address when calculating churn rates. That means that a churn rate also has to have some sort of timestamp, right? We're going to know the churn rate for 2019 or the churn rate for the last 4 weeks from today. You know, we as data scientists, we define these time windows, and then we calculate the metrics based on those fixed intervals. And then there's an additional layer, right, which is a more logistical complexity, which is the fact that this data tends to be very large. So, you know, calculating a churn rate from raw data requires efficient ETL processes. You know, you can think of, you know, writing efficient SQL statements or in Python or in PySpark, but essentially you want them to run quickly so that you can obtain these metrics in an efficient manner. And another thing I want to mention here is that in the context of churn, since we're talking about individual customer data, this data tends to be pretty sensitive. So there's a lot of personally identifiable information, PII, in this data that data scientists shouldn't have any access to, right? So the database administrator or data engineers put in an additional effort to add an encryption layer so that you know, a single row of data with customer information can't be linked to a specific person. So, you know, this is a part of our best practices approach when it comes to data engineering and making sure that, you know, since we're handling sensitive information, we can we're not linking this to any specific person in the real world. So yeah, I mean, if we look at the graph here real quick, you know, if we think about two different points in time, right? At point one, we're going to have a pool of customers, and then at point two, we're going to have another pool of customers, right? The people who are in both point 1 and 2 are the ones that are retained. The ones that were at point 1 but are no longer at point 2 churned, and then the ones that we have at point 2 and not at point 1 are newly acquired customers. So moving on to customer behaviors, right? We also want to leverage data on interactions between a customer and a product. And we're going to use the terminology event to label these sort of data. So in the graph here, each of these vertical lines represents a specific event for each customer. And an event can be a variety of things, right? When you can think of an event as a transaction, as a click, as a login. I mean, it depends on the product, and it depends on where the core of the churn issue arises. Or just to keep it as general as possible, I'll just refer to these as events for now. And so an event, to define what an event is essentially a time-stamped fact about customer behavior, right? And then using event data, we do some sort of aggregation over a specific time interval. That can be a calendar month or billing periods or a year, whatever you want. And then we generate a behavioral metric. And that's going to be a summary of customer events over a fixed time window. And we need to do this, right? Because a single event, and you can even see it in these graphs, just looking at a couple months here, a single event on one of these vertical lines is just a tiny pixel in a much larger picture, right? So when we want to do an analysis for all customers, we'll want to zoom out. And we zoom out by generating some sort of aggregated metric that summarizes all of the customer's behavior into a single number. That makes sense in the business context. I think we can move on to the next slide, Max. So now that we have churn calculations, right, churn rates, and we also have some sort of aggregations that on customer behavior, we can leverage both of these numbers, both of these data sets into creating a churn data set that's going to be ready for a more elaborate, a more sophisticated data science analysis. And so we do this in a framework that's called a natural experiment, right? And what I mean by natural experiment is that we're looking at past occurrences of churn, right? An outcome for a single customer is, oh, a customer churned or they didn't churn. So it's a binary outcome, right? And we're looking towards the past. We're looking at historical data to observe whether a customer churned or not. And this is essentially what I meant earlier when I said learning from data, right? Like this is a quintessential step in the data engineering workflow, and it can be relatively tricky, right? Because we're leveraging data from different sources, we want to leverage both churn and behavioral metrics to create a data set that's ready for machine learning. And in the end, what we expect to have, what we want to have, is essentially a data set. You can think of it as a table, right? Where every row is a customer at a specific point in time, and there's an additional column specifying whether the customer churned or not at that specific point in time. And then on top of that, you add all of the behavioral metrics that define the customer's behavior up to that point. So this requires a sequence of steps, right? We're pulling in both event data, metric data. We're defining specific time intervals. We're defining which of those intervals were active for each customer. And then we do that over a sequence of observation dates. And then, following that flow, we end up having, finally, we end up having a data set that's ready for machine learning, for data science. All right, so now that we have the churn data set, right, we can move on to more data science kind of work, specifically exploratory data analysis, where we want to start understanding some things about churn using the data. So we want to answer questions like, what is driving customer engagement, right? Like what keeps customers from churning? What are those variables? What does a healthy customer look like? What is their behavior? And then how do we deal with big data, right? I mean, we saw how we made all of these aggregations to get a churn data set, but this data set is also big in and of itself. It's just a little smaller, but it's still big. So we need to do some additional aggregations to make sure that we're generating business insights that can be interpreted business-wide. So a great application of exploratory data analysis in the context of churn is it's a process called cohort analysis. And what we want to accomplish with cohort analysis is we want to understand why customers churn and what keeps them engaged. we're using the churn data set for this, right? And we're identifying metrics that have a strong relationship to churn. So there's no complex statistics or machine learning involved yet at this point, right? Since we're still looking at historical data. But churn cohort analysis essentially allows us to compare churn rates in different metric cohorts. And by different metric cohorts, I just mean groups of customers, groups of people that show similar behavior. That means, you know, if you think back to the behavioral metrics that I talked about earlier, this simply means people that have a similar value for their metric. We put them into groups and then we analyze how, you know, what does the group's churn profile look like? So the main hypothesis, right, for churn is the following. If customers who are less engaged with the product churn more often, then a cohort of inactive customers is a cohort that we expect to have a higher churn rate than a cohort of more active customers. And I know that was a little wordy, so let's just go through the diagram to make sure that that the audience understands what I just said. So if we look here on the left at behavioral frequency, right, we can think of this as frequency of events. You know, for simplicity, let's think about transactions, right? So we're looking at, you know, for example, we're looking at the past month and we're looking at how many transactions occurred in the past month for every single customer, right? Customers who transacted 53 times, 34 times, like they're very engaged customers. And they have a generally a different profile than customers who have only transacted 2 times or 7 times, right? So by generating these groups, by generating these cohorts, we can also, since we have the churn outcomes, right? We can look at how many of these customers in each of these cohorts have churned. And what we expect to see is that the customers that have transacted many more times, the ones in this top cohort, tend to have a much lower churn rate than the customers in the bottom cohort, right? And this seems intuitive. I mean, it is, right? It makes sense. But there's a lot of value that can be added when we confirm this hypothesis using the actual data, when we run this analysis to make sure that, oh, our intuition is actually correct, right? And we can prove it to you by showing you the actual numbers. And you can do that by, you know, having an organized structure in the way that you analyze churn data set. So with that in mind, let's move forward into a demo that I created.
Yeah. Hey Juan, yeah, real quick. I just wanted to emphasize one point there. You know, Juan was talking a lot about transactions, right? By grouping these cohorts, but you can also think of these cohorts and different types of metrics, not just transactions. So website clicks, you know, how much times they've clicked on your website in the last hour. There's all kinds of things, and we try to keep the terminology broad with this event kind of terminology. But we are using, and we'll show you in this data set, we're using this similar data set that Chris showed in the previous presentation on using a transactional kind of set of data to work with to illustrate the example. But yeah, let's move on to the demo.
Yeah, thank you, Max.
I will share. Let me just log in and real quick.
Yeah, so I won't go over how to create the dashboard, and if you want to learn more about the specifics, just refer to Chris's previous presentation, since he did a really great job on showing how to create a dashboard from scratch. So we'll just quickly go over the content in the dashboard and just show how you can do a pretty simple cohort analysis using raw data, using the churn data set, right?
Sharing now. Bear with me. All right.
I'll quickly request control here, Max, just
Sure.
so I can hover over some stuff as I explain. Okay, so yeah, we're using the same retailer that Chris was showing in the previous demo, right? Contoso Electronics, an electronic retailer, and specifically we're looking at online sales data between February to April 2019. So we want to, the purpose of this dashboard, right, is to show how you can visualize the cohort analysis in Encorda And specifically what we're looking at here is event count, right? So an event in the context of this data set specifically means transactions. But if we were looking at another data set, an event could mean something entirely different, like Max just said. So with that said, first we can look at some KPIs here at the top. Essentially, in this entire period, February through April, what was the average churn rate for all customers? At different observation dates, looking backwards 28 days, what was the average number of events for all customers? Same idea, but looking at the past 7 days, what was the average number of transactions, the average number of events for all customers? And so, and we'll keep this similar theme going on here in the dashboard. We're on the left-hand side. We'll be looking at the last 28 days for different observation dates. And then on the right-hand side, we'll look at the last 7 days for different observation dates. So the first charts here are essentially for the entire period, February through April, we generated different cohorts depending on the event counts for all customers, right? So the first cohort here is going to be all customers in the last 20 that transacted or that had, 0 to 5 events in the last 28 days. And then on the y-axis here, we can look at the churn rate for this cohort. So as I said earlier, this chart confirms our hypothesis about churn, because as customers have more events, more higher behavioral frequency, their churn rate tends to be lower, which makes sense, right? People that have more events in the data set tend to be more engaged with the product, which means they're less likely to churn. And we can see the same thing for the data if we're looking only at the past 7 days. So let me scroll down here. So the column chart that we just looked at was an aggregated view for the whole period, February through April, but we can also drill down and look at the churn rates for all the different observation dates within this period, right? So the lines here, each of the different lines represent each of the different cohorts that are defined by the number of events in the last 28 days, last 7 days. And what we can see here is exactly the same thing that we saw earlier, just on a linear basis, right? So the cohort with the fewest number of events tends to have which is this blue line, tends to have the highest churn rate, not only in the entire period, but also in many different points in time throughout the period, right? And the same thing somewhat occurs in the last 7 days, although there are some dates where cohorts that have higher number of events have a higher churn rate. But in general, we see that the blue line tends to be on top for most of the time. And the reason why the graphs look a little different left to right is because when you're looking at the last 7 days, the data tends to be a little bit more volatile. There tends to be more variation in the data. So there's a trade-off between shortening the time period and then that increased volatility, that increased variation in the data that you're observing, that you're analyzing. And then lastly here, we can also look at some aggregations of behavioral metrics for each of the cohorts. So for example, average event amount, remember that events in this context means a transaction, right? So if we're looking at the past 28 days, throughout the entire period at different observation dates, what was the average transaction amount for each of these different cohorts? If we're looking at the past 28 days, what was the average total number of transaction amounts for each of these cohorts? So, and this is just a simple example with 2 behavioral metrics, but realistically you would have, dozens or even hundreds of behavioral metrics that you could visualize, and some of them are going to end up being more important than others in a data science context. But yeah, that's something that you'll start to understand as you carry out the analysis. And then lastly, if you want to look at it in a table format, you can do that as well in the dashboard here, where we can look at all the different cohorts, each of their churn rates, and on average how many events are occurred in each of these cohorts.
Cool. And then, yeah, just to kind of wrap up here, Juan, as you're looking at this data, right, this is kind of like sample data that we found. But these trends wouldn't exactly align to your business, and each business is a different situation, right? Where you might see different patterns based on the type of event, based on the frequency events and whatnot. And so that's why having some creativity and coming up with different features like last 28 days, last 7 days, maybe last 14 days, all this kind of stuff can help unlock some more value from your data and helping you to identify who's most likely to churn. And I will share back to the PowerPoint.
And while Max does that, I just want to reiterate, churn can be different depending on the business context, right? Events can be different depending on the product or service. But the set of strategies we've outlined so far, and which I'll cover in a second, can be applied to any sort of churn fighting context. So that's something to keep in mind. Just think about your business, your product. Are people engaging with it? If they're not, then these are the set of strategies that you can do to keep them engaged. Okay, so moving on to machine learning, right? We've done some cohort analysis looking at historical data, but now we want to move on to machine learning. And in essence, machine learning means we want to predict churn. We want to predict how risky customers are. When are they going to churn? How likely is it that they're going to churn? How can we forecast churn? And based on that, how much value is a customer going to bring to the product in the near future? How can we leverage machine learning? How can we increase our model's performance? These are all questions that we can answer, using machine learning techniques in the context of churn. So the first thing I want to touch on here is just a simple explanation of how a churn forecast works. So I'm going to cover a lot of information here, so bear with me. But essentially, what we want to do in the churn forecasting scenario is that at a high level, we want to help a business make data-driven decisions, right? We want to generate individual estimates of churn risk for each customer. And we can use many tools to do this. There are a wide variety of algorithms that we can do to generate a forecast. Here in the slide, I'm showing a simple, it's called the logistic regression algorithm that it's probably one of the most baseline machine learning methods to generate a churn forecast. So essentially, we're predicting whether somebody's going to churn, right? But you might be asking yourself, okay, but you're predicting when they're going to churn, but how far into the future is that? Well, that depends on the intervals on which we are observing churn, right? So if we're observing churn historically every month, then when we predict churn, we're predicting churn 1 month into the future. And essentially, to define what a forecast means in this context, it means it's a statement about future behavior. It's a statement about the future of a customer, of a customer's decision to churn or not. So we aggregate all of our behavioral metrics into sort of a customer engagement measure, right? Where our hypothesis is that more customer engagement will lead to a higher probability of customer retention. And to rephrase that using churn, it means more customer engagement leads to a lower probability of churning. Engagement itself is essentially a measure of how involved a customer is with a product. And then the forecasting model is evaluating this relationship. So we'll essentially have a risk profile in the near future for every individual customer. And we leverage this to know who to intervene with and, and how risky everybody is. And a great application of churn forecasting is a financial concept known as customer lifetime value. I'm sure some of you have heard of it. Just to quickly define it, customer lifetime value is the expected customer value. So that means revenues and costs over a customer lifetime. And since customer lifetime value includes expected future payments by a customer, so expected future revenue streams by a customer, it ties directly to a churn forecast, right? Where we want to evaluate the ROI of acquisition strategies, of customer engagement, customer retention strategies. We can do this, we can evaluate that ROI using a customer lifetime value framework and leveraging the churn forecasts to calculate those values for every single individual. So, just to simplify it here with a quick formula, right? Not to get into deep math, but essentially, when a customer is acquired, when a customer signs up, starts using the product, the company pays a cost of acquisition, a customer acquisition cost, which essentially means marketing or sales costs or any other channel that was used to acquire the customer. And then in that first period, the customer is going to generate some revenue from using the product, and then the business is also going to incur some costs of goods sold, which essentially is maintenance costs, which can be a variety of things: customer support, cloud computing, or anything else to keep the product or service alive. And so when we do this sort of analysis, we're assuming that we know the revenue streams for each customer, right? And knowing how knowing how much revenue each customer generates, we can look towards the future and think about how much revenue they're going to generate until they churn. And we'll know when they'll churn because we've forecasted that using the model. So the main framework here, the main hypothesis is the higher the churn risk, the shorter the lifetime of a customer, which means the shorter their value, the lower the revenue that they generate for the business. And then, if we want to push our forecasts to the next stage, if we want to improve machine learning model performance, we can leverage, more sophisticated, more complex algorithms to calculate churn risk looking towards the future. So, machine learning algorithm accuracy is essentially, that just means the performance of the churn forecast. And what do I mean by that? I mean, if somebody is labeled as a high risk customer, as somebody who has a high probability of churning, is that actually true? I mean, were they actually going to churn, or did the model give me an incorrect output? So the fewer incorrect outputs we have from the model, the better the performance of the model is going to be. And this is important because the interventions, the business interventions that occur later on, can be expensive. So if you want to target customers that are at high risk, you want those targeted customers to be customers that were actually going to churn, regardless of whether you intervened or not. And for that to be true, the model has to have a high performance. This essentially, which means that a high-performing machine learning model is going to lead to a more efficient use of resources when it comes to business interventions. And then another benefit of improving the performance is that you can also validate the entire forecasting analysis by generating different models, because despite the variety of algorithms, you can evaluate models using a similar set of performance metrics, right? So, and then you can compare these performance metrics using from different models and know which one's going to be performing best. And this is where you can leverage auto ML tools really to build a bunch of models in a quick and efficient manner, and then evaluate which one is performing best, and then use that one to forecast churn risk looking towards the future. So quickly here, looking at the slide, this is a quick example of an algorithm known as a decision tree. And here I'm using the context of credit cards. So the product is credit cards, and churn in the credit card context means essentially customers who are not using it. So the way a decision tree works is that we observe a single customer and we put them through a series of tests. So let's walk through this customer, this example customer here. Did they sign up for the credit card online? Oh yes, they did. Okay. Now let's go into the next test, right? Was their transaction count in the last month, in their last billing cycle or whatever, was it less than 50 transactions? Oh, okay, it wasn't. So let's move on to the next test. Was their credit limit greater than $10,000? Oh, it is. Okay, then the model knows all of that, and then it predicts them to be a retained customer. We don't predict them to be a high risk churner. Essentially, we can run this algorithm many times. The algorithm itself defines the cut points for each of these tests, and then this leads to a very high performing model that is very popular in the machine learning data science community nowadays, and can be very useful to predict churn looking forward.
Great, thanks, Juan. Yeah, and thanks for giving this illustration of a machine learning model. I know that when people think about machine learning, right, they think about it as a black box. And there's not a lot of, you don't know what it's thinking or how it's thinking on the back end. And this is just a simple illustration. Obviously, the machine learning models are a little bit more complicated than just this little simple decision tree. But what I do want to emphasize is, and Juan kind of alluded to it, there are there's been some great open source development in the last couple of years that has really tried to target that problem, where it provides prediction explanations for every prediction. So if you're in an industry like that's heavily regulated, like financial services, and you need to actually have the exact reason or reason codes as to why someone wasn't accepted for a loan, or why you gave this person a promotion and not this person. You can actually trace that back now, and it's repeatable and additive in how it adds up the variables used to make that decision. So anyway, so I can talk about that forever. We'll move on to the next slide here, and I'll hand it back over to Juan.
Thanks, Max. Yeah, just quickly here to wrap up and tie, all of this analysis that I've covered, all of its complexity back to the business, right? Remember that in the end, we're just trying to solve a business problem, regardless of how complex the statistics might get. It's still a business problem. We're trying to help your business make better decisions. So this is it's not an exhaustive list by any means, but here's just some quick examples, simple examples of how you can reduce churn through business interventions. So, one example is, improving products in general. Products have several features, and some of these features are engaging, some of them are less engaging, some of them can even be disengaging. So, there's a lot of value in identifying the good features, the best features, making them as accessible as possible, or possibly, even engineering new features that will keep customers engaged. Another strategy is executing marketing campaigns, right? And this is really where segmenting customers can play a huge role, because without the churn forecast, without the customer segments, you'll be marketing to all of your customer base, right? And that's not really an efficient use of resources. Whereas if you have a pool, a cohort of customers who have a high risk of churn in the near future, you can target those individuals with more specific campaigns that are meant to incentivize engagement with the product or service. Another strategy, is making sure that customer support is engaged with the customers, and identifying those customers that are in need. And need can mean a variety of things. It can mean somebody who maybe isn't using the product at its full potential. Maybe they don't know all of the features. Maybe they need to learn some new things and to use it in a more efficient way. And also, identifying the customers that are at high risk, the customers that we're predicting to be churned, making sure that the business is engaged with those customers, and promoting, incentivizing future engagement with the products. And then the last thing, sometimes it can be seen as the last resort, but it's something that can work with some products, is modifying the pricing structure, right? All customers that buy the product, buy the service, they have some sort of intrinsic value that they place on it, right? And then if the value of the product, if the perceived value of the product is higher than the market price, then the business itself can modify the pricing structure to make sure that these the supply and demand are at equilibrium. As close to equilibrium as possible. And this means understanding the relationships between the customer and the product as closely as possible. And all of these interventions are something that we can implement by leveraging the churn analysis that we've done up to this point.
Thanks, Juan. Appreciate that. I'll try to give us some time for questions, but I wanted to just wrap up real quick with how we can help you jumpstart your data science and machine learning journey. And what we've come up with is, and we've done in the past, is a fast start program where we can enable applied machine learning quickly. So this starts with whiteboard sessions. So us getting together with your executives or leadership or people that are close to the business domains, across cross-functional domains across the business, and just talking about what are some areas that they could use help in making better business decisions, right? And you'll be surprised, at the amount of things that people can come up with. And that what that helps us do is identify potential projects. I mean, and of course, if you already have potential projects, it's a different story. But if you come up with a list of potential projects, and then we have a suite of tools to help us, or a template to help us rank these projects by by really two main dimensions, which is deployability and return on investment measurability. Because at the end of the day, it comes back to the business, and we want to make sure that when we're implementing these models, that they achieve some sort of return for your investment in standing up the architecture and investing in data scientists, right? To come up with machine learning models. And so with the smart project selection, hopefully we'll pick something in that top right quadrant, right? That's very deployable. It's very easy to measure. Also has a good potential for ROI, right? And we can get some quick wins, and that's kind of great just to get some traction going, and being able to report that up to whomever and showing that hey, we're making progress with this, because by investing in this type of thing, right? If only like at an earlier slide I showed where there was like dozens of examples of machine learning, right? And where you can apply it. If only a couple of them work, you probably pay back for your team, for the investment in your data science team and resources. So that's something that we want to emphasize. And then another thing that we're very comfortable with is different technology stacks that are suited for your business and your business needs, and where you are currently. We're not just going to sell you on what we want to sell you on. We're going to make sure it works best for your needs. And in that process, that combines a suite of vendor kind of auto ML tools, modern data analytics platforms like Cohort, but also some open source technologies to create some development environments. And a quick anecdote to that is we helped a client set up some really pretty much across the board their technology stack, and it started with just myself being their data scientist, and now the data science team's up to 5 people. So and I think a big reason of that was because they saw that, oh, they've already made some traction here. They have a development environment in play. They have their data in one spot. It's like a dream for a data scientist to have all the data in one spot, easy to access, all there, and letting the data scientists do what they do best. So anyway, so if you are interested in learning more, please reach out to myself, and I would love to just if you have any questions, or schedule a whiteboard session, or we can go through how we can really help your business unlock more value from your data using machine learning and data science. And with that said, I will open it up for questions or Q&A if we have any of those. Moderators.
Yeah, thanks a lot, Max. Great presentation. I'll throw one out there for you. I think sometimes machine learning, data science seems like this big kind of intimidating thing to take on. What would you say to those out there, to kind of demystify that, that theory of it's too hard, right? I don't have the expertise in house. What would you say to people like that?
Yeah, great question, Ryan. So what and why I'm in it, right? So a little bit of background on myself, right? So my undergrad was in finance. I did I was in like more of a traditional management consulting kind of role. And I was doing a lot of Excel analysis, and none of my stuff was repeatable and scalable. But I was never like a computer science guy, originally, right? I love data, and I really enjoyed playing around with it. But when I started understanding like data science more and how I could make my analysis more sustainable for my clients without me being present, I realized that there is so much open source technology available in these domains that help speed up your process, and a lot of really smart people and PhDs that put out open source algorithms and models that you just need to figure out how to apply to your business problem. So you don't need to know everything. You just need to know how well does it perform on your test data set, right? How well is it going to generalize to the problem? And you measure the accuracy of the model. And to make it even easier, right? Like now there's a whole suite of auto ML tools, and one in particular that I've been using a lot recently is Data Robot. And what I really like about it is it runs, tons of models by like on its own without you having to pick the models. You specify what you're trying to predict in your data set. It does a bunch of EDA for you. And it also handles like data, like text data and data that's not exactly ready for a machine learning model. It handles all that for you. So it's a lot quicker. So something that would take me 2 weeks, I can do in an hour with this. And really you can train anyone to do it, I believe, and get a savvy business analyst kind of working with this technology. And then in addition to that, right, like there's there's engineering components of this as well, right? And what I also like about the AutoML tools is that it allows you to deploy things a little faster, because they typically have a deployment mechanism already built in-house with a API already set up, so it's very easy to integrate with whatever your current technology stack is.
Yeah, that's great. Just looking here, we got about 5 minutes here. Well, I think this is a great presentation. I think anything else you wanted to add, Max, as far as you know, kind of where you guys are taking some of the data robot integration and how we can expect that to kind of promote up through our data science team here at eCapital?
Yeah, sure. So, you know, no, I think one thing, right, is that, you know, and I don't know if we touched on this I think we might have touched on the previous session, but what was really attractive to me when I started working at eCapital as graduating from my master's in data science was Encorta, because it had you know, a lot of open source technologies already well integrated within the product, like Spark and Python, two things that you need for data science, and have become kind of the standard, right? Especially Python, and Spark helps you deal with bigger volumes of data. But because it's so well integrated within the product, you can now leverage anything else within the Python ecosystem within Encorta, as well as tools like DataRobot that have their own Python API wrappers. So what we've been able to do pretty easily at a previous client is, you know, set up some problems, you know, achieve some results in some of these models for different case studies, and then be able to integrate it well within Encorta, because Encorta handles all of the data flow and the ETL kind of, or ELT even, right? But you know, all the data is in one spot. You can orchestrate how it comes. You can pre-process it to just to the point where it needs, and you don't have to go crazy with it, because then the AutoML tool can take it from there, and you pass it through API, get the scores back, and you can publish it in dashboard and augment your business, right? And so you're augmenting your business process. So, you know, that's kind of where I see, you know, how you know, we can really help. But of course, we're not just limited to those tools and you know, and technologies.
Yeah, absolutely. I love that message. I think it resonates well and kind of comes full circle almost with Matthew's presentation this morning, right? Of almost running analytics on your analytics, right? And I think, you know, some of what you guys are doing here with machine learning is a great stepping stone, you know, into that type of a platform. So yeah, I would encourage everybody, you know, reach out to Max and Juan here, you know, find them on LinkedIn. Max has his email here. Certainly be doing some follow-ups with those who are interested on the data science and machine learning side. But would definitely encourage everyone here on the call today to give it a shot and explore it, right? I think we've seen a lot of success. You know, we're talking, you know, weeks, not years here, right? So I think we can help you become dangerous very quickly with your data and ultimately unlock the potential. So,
yep.
Thanks a lot, guys.
And these whiteboard sessions are free. Oh, I was gonna say, and whiteboard sessions are free, right? We're not charging for these. So happy to help you think about the problem.
Yeah, and that's a great point, because it does start with the business problem, right, Max? I mean, when you guys sit down with the companies that we partner with, you know, we're not doing a deep dive into the technical to start out with. We really want to understand what drives your business, what are you doing to operate your business, and ultimately try to help you succeed in those manners. So,
absolutely, starts and ends with the business.
For sure. Well, thanks a lot, guys. Really appreciate it. I know we're about to hit